All right, so last time we talked about getting rate price from off chain using protocol, and we use the chainlink protocol from the Chainlink GitHub repo, and then we were able to call some functions from the interface. We imported this interface, okay, imported an interface, and then we used the interface, excuse me, in our funding contract, okay. All right, so today we're going to be talking about loops. So very fast, I record this one then. All right, so I'll just copy this guy and paste it here. Okay, so what are loops? So let's talk about loops. So what are loops? We just copy this one and paste this here as well. Um, okay, so loops allow you to iterate through data and take functional actions. This is supposed to be action. Take functional actions depending on the data. Okay, so a for loop is used to repeat specific block of code a known number of times. For example, if we want to check the grade of every student in the class, we look from one to the number. All right, so we we did array. Understand? We learned about array, and we we said that arrays are sequence of data, understand, of the same type. Okay, and then loops is what we use in iterating through data. You understand? Let's say like an array or any set of data that's together, we can loop through them and then do whatever we want to do using that particular operation altogether. Now let's say let's write an example. Okay, so remember we did um, oops, let me see. Okay, so let's write a simple function. Remember the assignment I gave some time ago when I said that I should check um modulus of two numbers. Okay, we check if two numbers is divisible by each other. Understand? Okay, so let's just write that function, and then let's just write that function and use it as, okay, I'll call this guy check validity. I'll call this norms, and public view return units. Okay, so for us to check that, we write an if statement. Okay, so say that if if norm modulus.
So are there no state variables?
No. We are not getting any state variable. It's just an input. You're just checking an input. Let's say, for example, put in two numbers. Now we want to check if those two numbers are, you know this thing now, you're supposed to know this thing now. What's the essence of putting a state variable? We're not putting any state variable yet. In fact, there's no need for a state variable equals to 0. Okay, so we can say that if this is that, should return true. Understand? Okay, so we know that if it is not, if it's the opposite, so no need to write, no need for writing else. You understand? The else statement. So if you run this guy, you understand, it's going to, okay, I think I have errors.
Return. You're not supposed to return uint
Oh,
now.
sorry, I'm supposed to return bool. My bad. All right, so all right, so we don't need to write. You're not supposed to write else if sorry, the else statement. You already know that we're going to run this guy. It's going to return false. All right. Once this statement is not true, it's going to return false. Okay, so let us write okay, let us create an array. Okay, I want to show us loop. Let's create an array. So let me call this guy um public. Let's make it public. Let's call this guy list of numbers or number lists. Okay. All right, so we are going to be creating a static list. Understand? We're going to be creating a static list. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So I'm going to be creating a static list. All right. So I want to write a constructor. Okay. So to do, then need to write in a constructor. We're not getting any inputs here. So let's write constructor and let's call this guy um this guy to make it let's not write constructor. Let's just go straight to the point. So let's just write function and then let's make this guy let's call this guy check multiple. All right, so this guy is going to get an input, call a number. Okay. Excuse me, sorry. So it's going to get an input number. Now, what we want to do is that we want to iterate through this loop. Okay. So what we want to do is that, okay, so what if we check the multiple of a particular number? So say that how many numbers can be divided by 2 in this particular array? Okay. We can say how many numbers can be divided by 5 in this particular array. How many numbers can be divided by 3 in this particular array? If you The numbers that can be divided by 2 here is 1, 2, 3, 4, 5. Okay, 5 numbers can be divided by 2. So when we look through this particular set of numbers, the answer is supposed to give us 5. Okay, if we say how many numbers can be divided by 4, that is like how many numbers will be let's say 4 modulus that number that will give us 0. You understand? That means it's divided by that. You understand? So here is going to give us 1, 2. So only 2 numbers. The answer is going to be 2, and so on and so forth. So we want to look through this and then see the modulus of. You understand? So we could say that how many numbers can be divided by 2. So we have to look through this particular array to see, to look for the numbers that can be divided by. You understand? I don't know if you understand. So that's what we'll be doing. Okay. So, oh, yes. All right. We want it to return an integer. Okay. So, um, okay. So for us to do that, we are going to be writing loop. You understand? So for us to do that, we are going to be writing a loop. And also for to write a loop, loops have there are there are 3 statements in writing loops, 3 key statements in writing loop. I call it 3 key statements in writing for loop. Okay, that's specific for loop. All right. So number 1, we are going to be initializing the start of the loop. Okay, so we initialize at of the loop. Okay, so how do we initialize the start of the loop? So we are going to be writing the for loop using the for statement. All right, so we're going to be using what we call index. All right, and index we're using I to represent index. So we are going to be using I to represent our index. Okay. So first of all, we're going to be initializing our loop. Initializing our loop is that which number is our loop starting from? Where are we starting looping from? Are we looping from 10 to 1? Or we are looping from 1 to 10 altogether? So are we looping from 10 to 1? Or we are looping from 1 to 10? Okay, so in this array, we are looping from 1 to 10. So we are starting our 1. So say index, which is I, is equal to 1. Key statement that we are going to be writing is we are going to be determining the length of the loop. Understand? Okay, so let me write it down. Determine the length of the loop. Okay, so how do we determine the length of the loop? All right, so remember that we are working with index. Okay, so this is our array. This is where we are looping from. You get, so we'll say that our index, which is our I, should be less than. Okay, so we're going to use this less than this our array. Okay, so we'll say this our array number list dot length. Remember the dot length we used when we are writing array to get the length of the array. Understand? If you are confused about this length stuff, you can still go back to array to look at it, go back to the video and and look at it. All right, so we'll use this dot length to make sure that our loop doesn't exceed the um the length of our loop, sorry, of our array. So if we have 1 to 10, so index cannot loop above 10. So it's always going to be less than 10. Understand? It's going to be always going to be less than 10. Understand? And so the last state, the last one is going to be 10. So it's going to end in 10. Sure you get. All right. So the last statement, which is okay, the last statement is to um define how it's going to run. Understand how the loop is going to iterate through the array. Understand? Okay, and then the direction, how as per the direction of the of the loop. Understand? Okay, so by that we are going to be defining the direction of the loop, how where it's going to be looping through and how it's going to be looping. Understand? So we'll say that to direct the index. Okay. All right. So how do we do that? All right. Okay. So that we can say that I is equal to I plus 1. Okay. Now we are saying that I is equal to I plus 1, meaning that remember how we wrote our increment. That means after every loop, add one step at a time, one step at a time. So it goes from here to 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 here. So it starts from index 0 to index 1 to adding 1 to our index and then saving it back to our index. So talking about increment here. All right, so instead of us to write it this way, we can just come and write it like this and say that index plus plus. Okay, so this is also the same thing with the first one we wrote. You understand? So we are incrementing it by 1. So after every loop we go to the next one, after that one we go to the next one, after that one we go to the next one, after that one we go to the next one. You understand? So that is these 3 statements. Okay, so after that you now this is where you write your code. Okay, remember we said that loops allow you to iterate through data and take functional actions. All right, so we have done our loop setup. Now let's write our functional action. Okay. All right, so let's write a functional action. All right, so let's create a state variable here. Okay, let's create a state variable here. Let's call it count. All right, so count is going to be units. All right, so we want this loop to want to create somewhere that loop is going to be storing whatever information is going to be gathering while it runs through our array. Okay, so we're creating a state variable. I say state variable. a local variable here. We'll call it and we'll initialize it to set it to 0. All right, so we'll know briefly why we're setting it to 0. All right, so we can now say that if now we are going to be calling this function. All right, we're going to be calling this function because this loop is going to be using this function to calculate these our multiples. Okay, we're going to know that there is no function here to actually do that mathematical calculation. Here it's just going to loop through the numbers without any action. So this function is going to be doing the calculation for us, this modulus. So we're going to be calling it here. Okay, so we'll say that if check validity. Okay, so we're not going to be using these two numbers. So I'm just going to say um
So how did you do that thing that thing just appeared like that?
okay, they will definitely show you. It's going to show you, you understand, names of whatever you have called by that. You just have to press your tab and then it will complete it for you. You understand?
Yes, yes.
Okay, so I just call this guy. Okay, let me put this guy inside of here. All right, so okay, so we're saying that if this is this, and then we should return this, and then let us let us let's return. Let's return count. Okay. Okay, so let's just check our stuff. Okay. All right, sorry. All right, so
So
okay, that
someone is
one
raising
is
a
appearing here. Oh, sorry. We didn't declare our stuff here. So what other error are you bringing? Okay, so now if we are to run this guy and so let's just deploy this guy. I think we don't have a wallet here to deploy with. I don't know. Okay, we have now. So Okay, so let's deploy this guy and see. All right, so we are going to put in two, check validity, and oh, sorry. So let me do two and check. All right, you see that if I put in two, you'll see that the answer is five. All right, if I put in four, see that the answer is two. If I put in, what's the other number we say we're going to check? Eight. I put in eight, see that the answer is one. If I put in one, see that the answer is nine. So one can divide all through nine of them. Understand? So if I put in five, okay, I put in five before. If I put in three, see that the answer is three. Okay, so how is this possible is because we looped through this array. And then while looping through this array, we are doing this guy. All right. While looping through it. So when we put in five, okay, so it's going to go through one. Five modulus one, zero, no, five modulus one, cannot, five modulus two, five modulus three, five modulus four, five modulus five. Five modulus five is going to update count to one. Five modulus six, five modulus seven, five modulus eight, five modulus nine, five modulus 10 is going to update count to two. You understand? If I do three, it's going to start with one and start iterating through this array while doing this function, okay, while running this guy. You understand? So we're using this guy to check this guy. All right, so that's that for loops. Okay, so we use loop to
Mr.
iterate.
Samuel.
Hello. Yeah,
Yes, Mr. Samuel.
I can hear you. I can hear you.
Please, can you explain this line of code starting from the four? Like the line of code starting from there.
This
Yes.
this guy.
Yes.
All right, all right. Okay, so I said that when you are writing loop, you have three important when you are setting up your for loop. When you are setting up your for loop, okay, you have three important statements you are going to be writing. One, you are going to be initializing your loop. Two, you are going to be determining the length of your loop. And three, you are going to be directing the index after each turn. All right, so let me explain each of these statements with the setup itself. Now, when we were writing our loop, we said that first thing is to initialize our loop. So when we say that we declared our index, all right, so when you are writing your loop, you mostly write index. Okay, so we initialize our index to be one. So this I here represents index. Okay, and so we said that this index is a uint. Okay, now we said that this index is a uint, and this index is going to be starting with one. So our um um loop is going to be starting from one, which is this guy. Okay, we're starting from one. All right, and then we said that initialize the start of the loop. Okay, so initialize the start of the loop. So we are going to be saying that, sorry, that's what I just explained. Second one is determine the length of the loop. So how do you want the loop to run? Okay, so imagine that you want to start loop from 10 to 1. Understand? You want to start your loop from 10 to 1. You get? So we are saying that the I will answer that briefly. So we are saying the second statement is that determine the length of your loop. So we are saying that this index, which is equal to 1, is starting from 1, but it's going to run through this array and not exceed the length of the array of the list. Okay, so we said that this index is less than our array. Remember, our array is number of lists, so we called it here dot length. This dot length fetches the length of our array. So when we say that number list dot length, we're actually getting the length of our number list, and we're saying that this index is not going to run past the length. That's why we're saying I is less than number list dot length. And then lastly, I'll say that to direct the index after each turn. So we're saying that we are moving from left to right. We are moving from the smallest to the biggest. So it's going to be an incremental format. So after 1, it goes to 2. After 2, it goes to 3. After 3, it goes to 4. Just like that, one after the other. Okay. So that's how it's going to run. Now, if we want to count from 10 to 1, okay, we want to count from 10 to 1, how do you think we should set it up? Hmm? How do you think we should set it up? If we want to start our loop from 10 to 1, we want to start from here down to here. How do you think we should set it up? All right, quickly. Somebody should just answer me.
Okay, I think we'll do for units index will be equals to 9 because I think index starts from okay. Index will be equals to 10. Then index will be less than greater than number list dot length. Then I minus minus.
All right, so I'll give you 80. 80 is because you got everything correct except the I um is greater than. I cannot be greater than. We want our loop. Remember I said that to determine the length of our loop, so it doesn't really affect whether it's going right or left. We are just setting up the length of our loop. So if we are going right, we are going to be determining it from our initializing to our direction. Understand? Where it's going to and how we are initializing it. So if starting from our left, you understand, but we are still maintaining this guy as our length of the length of the loop, how far we want it to go. Okay, so if we want it to be you want it to stop in 6, you can come here and say less than 6, you understand, or less than or equal to 6 or whatever, understand. But if you want to iterate through the array and not go past it, you understand, so that you don't get overflow, you you define it here, you understand. And then if you are going backward, definitely it's going to be minus minus decrement. Okay, and then you are going from, and then it sets this place to 10, so you are starting from 10 to 1. Okay, so that's it. We understand that line here. All right, so we now write an if statement, which is our code, and then we say that if um we're not checking our, this check validity now is now our function. Okay, so we're calling this function check validity. Okay, and then we put in and say, now remember this guy has two inputs, you understand, um norm and norms. Okay, norm and norms. So definitely this our, when we call it here, it's going to definitely have two input as well. And then we said that our first input is going to be the index, num index, and then the second input is going to be our number, this number here, you understand, the number we're going to be inputting, you understand. So if we put 3, it's going to be um is going to be running the modulus of our inputs to our index. Okay, so what we are running. So when we say the number in the index formation position, sorry. So when we say number and number, that means we are doing this modulus this, and then whatever answer is going to give is going to return the count. So it's not going to return the modulus, it's going to return the count. So whatever we are looping, we are storing it in zero. We say we are initializing to zero. Now the reason why we initialize it to one is because our count is initialized to zero. You understand? So the index is zero. And the index is zero. So it starts from one and start initializing and counting like that. Remember, modulus cannot be modulus zero. You understand? So it has to be one. So it stores whatever happens here in count and give us the increment um here. Understand? So it doesn't stop counting until it gets to whatever. So we can increase this guy to 100, we can increase this guy to 1 million, and then can loop through every of them in a second and then give us an answer. Understand? So what?
I'm sorry to interfere. Quick question. You said you can increase it to 100. So
Yes,
does that mean we have to type out from 1 to 100?
sorry.
Like, does it mean if you want to increase it to 100, we have to type the numbers from 1 to 100? Like, the number list now, our array. Are we going to have to type everything out 1 to 100?
No, we don't have to type from 1 to 100. Have I answered your question?
No. You said, because the numbers we have here, we actually typed out our array 1 to 10. So if I want to do like 1 to 50, am I going to have to type it out? Or is there a way I can just signify the beginning and the end of the array?
Yes, there's a way you can signify from beginning to the end. There's a way you can actually set your loop from, let's say you are creating a a static loop, for example. There's a way you can just create for 1 to 50, 1 to 100, and the rest and the rest and the rest. Okay, so let's try something else. Okay. Sorry, I'm having network issue since something is still loading in my system. Sorry, my system is hanging. Oh, Jesus. Okay, so thank God. All right, so let's assume that we have something like this. Okay. I'm coming. Let me try something. All right, I'm coming. Just give me a few seconds. Okay, so what if we create a um how will I put it? Like I've not really thought about this before. Like thought about it, like thought about it. But there's a way. Let me try something out. So okay. Okay, see, I'll check it and then I'll get back to you. Okay, with the method I'm actually working with, it's not actually working right now. So, but I'll check it and then get back to you. What's happening?
So what did you say?
Can you hear me? Can you hear me? Can you hear me?
Yes, sir.
We can hear you.
Mm-hmm. I said I'm going to check and then I'm going to get back to you. I've not actually done it before. So I'm going to check and get back. I'm going to check and get back to you. The method I'm using is not working.
All right, so
Okay. My system is actually hanging. See, I can't touch anything. So let me just refresh and okay, let me try something. Let me try something. I'll show you. Okay, so I'm trying to refresh my system. So I refresh the premise IDE, but um you can actually rename this array. Okay, since you are writing a dynamic array, you actually rename this array and then create um sorry, I say dynamic, a static array. Like create a static array and give it a particular number. Let's say you want it to be the size of 1000. Just give it the size of 1000. So when you are looping, it's going to loop from 1 to 1000. So the last number of an array is its actual size of the array or the length of the array. So if I, oh god, I don't know why this thing is. Okay, I think my stuff is reloading, so just wait. Try to refresh. Yes. Sorry for my network. Okay, so if you are with your laptop and then you are coding with me, just try this out. Okay, so after creating your array, you understand, in the place of that, your um static array. Okay, so just name the array and then give it a size. So if you want it to be 50, so just say bracket 50. Okay, if you want it to be 1000, just say brackets 1000. So it's going to be um
Sir, please, I can't see
wait,
your screen.
yeah, my screen is, I'm still trying to load. It's still loading. Network is very, very bad. Network is very, very bad. Yeah, I'm trying to reload it. So are you seeing my screen?
Yes.
Okay. Okay, so let's say you want to create an array of size, let's size what? Let's say size 1000, for example. So we say, so if we deploy this guy and let's see what we've got. So if I check 20 core, I don't know why it's not giving me an output. I check 10. So it's calling, but it's not giving me an output. Okay. All right, so this guy is working, but it's not giving me an output. All right, so I will check it and then I'll get back to you. I'll answer your question. Probably might not be in the class, but I'll drop it in the group. Okay. If I'll drop it in the group, or if I don't remember to drop it in the group, I'll talk about it in the next class. Okay, it will be the first thing I'm going to address in the next class. All together. All together.
Yes, sir.
All right. And then lastly, um, you can also check it out as well. But if you can't check it out, no problem. Wait till our next class when I'll fix it. Okay. All right. So okay, that's it for loops. Okay. So let me just rush before our time will be exhausted. Okay. Let me just rush and take two more. Probably we'll talk. I just talk about libraries and probably talk about SafeMath, and then we'll now apply this loop and the library in our in our projects, in our fund projects. Okay, so libraries are quite similar to contracts, but they are different. Okay, let me just create call this guy library. So okay, so what are libraries? I think I prepared a very brief note to that effect. Let me just copy and so I said that libraries are similar to contracts but are mainly intended to for reuse. Okay, so write libraries basically for reuse. Okay, that's one. Secondly, a library contains functions which other contracts call. Then thirdly, there are do's and don'ts of libraries in Solidity, which they are libraries can be called directly if they do not modify states. Functions can only be called from outside the library. All right, but there are exceptions to this. Then secondly, libraries cannot be destroyed as it is assumed to be stateless. Libraries cannot have state variables, and that's why they cannot be destroyed because they are stateless. And fourthly, a library cannot inherit any other element. All right, and then fifthly, a library cannot be inherited. All right, so you don't inherit into library and you don't inherit library. Okay, you don't inherit into library and you don't inherit from library. Okay, so so that's it for libraries. So libraries are used to write to create your own types. All right, it's another way of creating your own types. Okay, and also we use libraries to create functions that can be reusable. Understand? We can use it to create functions that can be reusable. Now let's take for example, let's take a very simple example of libraries and how they function. Okay, so let's create a library here. So okay, let's create a library that let's create a library that searches through an array. Okay, let's create a library that searches through an array. Understand? So first of all, we are going to um, be creating a library. Let's call this guy search. All right. All right. So we're going to write a for statement. All right. So we're going to be using this library as our iteration type. Like whenever we want to loop, we'll call our library. Understand? A library helps us to loop through data. Okay, helps us to loop through data. Understand? All right. So we're going to be writing our library. So remember how we call our sorry. We're supposed to put this inside a function. Sorry. So let's call this function. Um, okay, so let's call this function index of. Can't think of a better way of calling this guy. All right, so this guy is going to be having now. If we want to be looping, if we want to loop through something, okay, if we want to loop through something, we have to have what we are looping through. Okay, we have to have an array that we are looping through. And remember, most times, all the time, we have been writing an array, we have been writing it in our state variable. But in this library, we are not allowed to declare state variables. All right, so we're going to be writing our array inside of this function. Okay, so we're going to be writing it like this so that, and then we'll put it in storage. All right, and sorry, we're going to call it, let's call it self so that let's call it value. All right, so it's going to be public. Let's call this guy. Let's just make it view returns. Make it viewings. Okay. All right. So let's create our for loop. Understand? So once the loop to return the index of or the value of the value of some integer or something like that. Okay, so when we loop through it, it's going to give us the position the integer is. So when we put in, let's say we are looping through numbers of 1 to 5. Okay, so if I put 5, it's going to give me 4. If I put 2, it's going to give me 1. If I put 1, it's going to give me 0. Give me the index of the integer. You understand? I don't know if you get. All right. So what we're trying to achieve, I'm just telling us what we're trying to achieve. So what we're trying to achieve is that when we look through this guy, understand, and then we put in our number, it's going to give us the position where that number is. Okay. So that's it. So we are going to do our setup the same way we set up the, remember how we set up our loop when we were talking about loop earlier. All right, so to create our index. Okay, so index, and we're going to set our index to 0. Okay, and then we are calling this loop. All right. So we're going to say I is less than, so length. Okay. So, and lastly, we said that it's going to be 1 1 1 1 2. So it's going to be plus plus. So said if self, which is an array of index, is equal to value, okay, return I. All right, so let's make this guy proper. Okay, sorry, to the double hash value. All right, so now we just written our library. Okay, so this is our library, and then we're saying that this guy is going to loop through a particular value. All right, so it's going to have two inputs. It's going to have the number, and it's going to have its index. All right, so if the number is the same with the index, okay, so if 0 is 1, is in position of 1, it should return its index. Okay, so if 0 is equal to 1, which is the index from this array, is equal to the value, it should return the index. So if I put in 5 in the array of 1 to 5, if I put in 5 and then the position is equal to 5, it's going to return the index of 5, which is 4. Hope you understand. All right, so
Yes, sir.
all right, so let's write a contract. So this guy is your library. So let's write a contract. Okay, so let's call this contract um test library. Okay, so we're going to be creating an array here. Let's call this array my data. All right, so we are going to be statically be pushing in some numbers into this array. Okay, so let's push in some numbers into this array so we can. So let's push in sorry, let's push in 1. So for the sake of this class, I'll just manually push in 5 of these guys. 3, 4, 5. All right, so 2, 3, 4, 5. Okay, so I just manually pushed 5 data into my array. So let's write a function to actually, but there are better ways of doing this. You understand? There are other ways of actually doing this, and then you could actually create a static array of 5. All right, you could create a static array of 5. You understand? You could leave it open, you can leave it dynamic, so you could write a function to actually push in these numbers yourself. Okay, and then so on and so forth. There are different ways you can approach this particular challenge. Right, so let's write the function. Okay, let's write the function, validate. Okay, check value. Let's call this guy check. Let's call this guy check value. And then let's say the input is var. All right, we're going to be making it external. All right, because we wanted to call our library. Understand? So external view returns. We're going to be returning units. Okay, so units. Now want to call this our library. All right, I want to call this a library here. I remember we had a declare the variable here and an input here. We call it value. Okay, so and we created an input here again. We call it var. All right, so we'll say that value, which is what we called here, is equal to var, which we called here. So whenever we are calling var, whenever we have an input in var, it is actually the same thing as value. Understand? So let's do the index something. So say that index is equal to our library, which is search dot our function, okay, which is index. Okay, so it's giving us the 2 inputs of, now you see that it's automatically giving us the 2 inputs of our function index of, okay, which is self and value. But we want to be getting not this array, but this array. Understand? And then not this value, but we say that this value is this value, so we are safe to leave this particular value. All right, so we'll just call this guy my data. So we already said that this value is this value, so no need putting this value again. Understand? So whenever we impute this value, it's going to be stored in this value. Understand? So when we get this index, when we are getting this my data, my data is actually this array, but this value is actually calling from this value. Remember, we are calling the function from search, which is our our library. Now you see that we are using our library as our data type. Okay, we are using like our library as our data type. Now this is our data type, this search. Now we are using this search now as a type. So whenever we want to run this particular function, we can use this library again and again and again. We can create another contract and then still use this particular library again. Now mind you, okay, now let me return before I forget. Let me return this. Now, mind you, the reason why we are not importing library here is because everything is in the same file. Okay. If this library was like somewhere else, or let's say like we're importing a library from a GitHub, okay, we're going to be doing the normal importation the same way we imported that aggregator v3 identifier, something like that. Understand? The same way we imported our interface. That's how we import our library as well. Now we're not importing because we created a library in this same place. So when I save, I'm not going to have any issue. I'm not going to run into any error because the library is in this file. Okay, when we are going to be using it in uh fund me contracts, okay, you are going to see how it works in real time. All right, but this is just an example to tell us how libraries work altogether.
Yes, sir.
All right, so let's run this and let's see what it's actually doing in real time. So I'll just delete this old contract and deploy this guy. Oh, sorry, test library. So I will test my library. And so if I put 2 and call, it's going to give me the index of 2, which is 1. If I put 5, it's going to give me 4. If I put 3, it's going to give me 2. So it gives me back the index of the number. All right, it gives me back the index of the number. So you can go back your own personal time and see how you can change this so that when you put in the particular index, it's going to give you the number. Understand? So if you put in 0, it's going to give you 1. If you put in 1, it's going to give you 2. If you put it 2, it's going to give you 3. Understand? So at your own pace, after this class, just go and play with it and see how you can change it. Okay, so that when you impute the index, it gives you the number rather than when you impute the number, it gives you the index. Okay, so um, that's it. That's it for libraries and for loops. Okay, so with this little time, let me just touch safe maths. All right, so in this little time, let me
I have
just
a
touch.
question.
Yeah, please do ask your question.
Let's say we're importing whether interface or library or anything, let me say from a GitHub repository, right? Can we
Yes,
just copy the code and save it in a file?
that's why I
You get
said.
like
That's why I said the last class that when you are importing, you can say you can go to the GitHub, copy the code, and come here and create a new file for it. You understand? And then just import it from the file rather than importing it from the GitHub. Okay. So just import it from the file. You can do it like that. You can, but it will make your code bulky. You can just come and copy it the way this library is here now. just copy it here and then just use it like that, okay? And then that one will make your code very, very bulky. And then you can create it and then you can export it directly from the GitHub. The same, just the way we imported from when we are writing
Simple
um
stuff.
simple storage. That's it. Okay, that's it. So you can
Okay,
copy
sir.
and but to make it to me I feel it's stressful. So why not just instead of copying and pasting, why not just get the directory and just import it to your you don't have to there's no need editing the code already. You want to use the functionalities in the code. So no, if you won't be editing the code, you won't be working on the code. So I feel personally, I feel there's no need copying and pasting it in your file again so that you now start having many, many files. So you should just know that the files you are having are the ones that you created and you're working on. So any other file you're importing it from from abroad.
Okay, sir.
All right. So um okay. So lastly, let me just talk about SafeMath. Um. Okay. Yeah. Let me just talk about SafeMath for the sake of this class briefly. Think you should know about it. Let me just copy this. Okay. So what are SafeMaths? All right. I didn't write a code on this, but I just feel like you should have an idea. You should know about it. Okay. So what are SafeMaths? So SafeMaths is a mechanism that help us to check um so that it's another mechanism for checking overflow. Understand? And in older version of Solidity, okay, so let's say in let me change this to 6. Okay, so let me come to my compiler and change it to 6, version 6. In older version, say let's say version 6, let me use version 6.7. Okay, so in older version, let me create a contract and audit save maths tester. Okay, so let's create a state variable. So let me make this guy 8. All right, and public, call it max number. All right, so the max number of unit 8 is 255. All right, so now SafeMath is a mechanism that helps us to not exceed this so that we don't have an overflow. You get? So let's say we write a function and call it add. Okay. I'll make this guy public. All right, so we said that max number is equal to max number plus 1. Okay. Before I proceed, quick question: is there a better way we can write this guy? Is there another way we can write this max number is equals to max number plus 1?
You can do math number equals to math number plus plus. Will it work?
No, it doesn't. That's an increment. Okay, there is this operator. I taught us when we're talking about operator, and I said that when we say plus equal to, we are saying that it's the same thing as when we say mass number is equals to mass number plus 1. So we are saying that the value of mass number, you should add 1 to the value of mass number and you should save it inside mass number. I don't know if you remember. Okay, so this is a short form of writing it. All right, so if we compile this, okay, and then we deploy, all right, you see that. Let me delete this old contract. You see that mass number is 255. Okay, so if I add 1 to it, you see mass number becomes 0. You get? Now, what happened here? This what mass number does is that what this SafeMath does is that it helps to check so that we don't exceed what we've said here, what the mass number is supposed to be. So when we said that the mass number here is 255, so when we try to add 1 to 255 to make it 256, it returns us back to the lowest number, which is 0. Okay, so if I add, okay, so I check, you see that we've added 14 to it, so we've added 14 times. All right, so it starts all over again. If I add till we get to 255 and then I try to add one more, it will start again. It will start all over again from 0. Understand? So that is SafeMath. All right, there is a library for it. Let me see if I can actually get the library. Okay, I think I have it now. Let me share my screen and show you. All right, so this is the um the extension for it. Okay, so you can actually call this to your smart contract, but what this code actually does is what I'm explaining here. All right, so that's what I'm explaining here. Okay, so what it does is that it helps to check so that it doesn't exceed its bandwidth. Understand? Its limits. Understand? So I said bandwidth. Its limits. She gets. Now, this is for older contracts. All right. This is for older contracts. Now, in the newer contracts, understand. Now, this method is using the uncheck. If I forget, using the uncheck method. All right. So, in the older version, it uses the uncheck method. You get. Now, in the newer version, so let me show you how the new version is. So let's just make this guy 8.7. We come back and we change. Sorry, change our compiler to 8.7. Now, if we do the same thing and then we compile it, okay, if we do the same thing and then we compile it, okay, so let's just compile this guy. All right, I think it's synchronizing with our version, so just wait. Okay, our contract is still compiling, but if remember how the old version works, the uncheck method works. So when we compile it and then we try to exceed the limit, it goes back to 0 and start afresh. Understand? In the newer version, what it does is that it will not run at all. It's going to flag error. Understand? I just wish this guy will compile very fast so that I'll show you. I don't know what's wrong with this guy. Still compiling. I don't know whether it's network or what.
Sir, Mr. Samuel,
Yes, I can hear you.
can't we just when we declare our state variable using public max number, then we'll come and use required so that max number cannot be above 255.
Yes, we can. But this particular now you see that every unsigned integer has sizes. Now let me show you. So if I come and click on, let me write unit again. Now you see that we have different sizes. We have unit 104, unit 112, unit 120, unit 128, and all that and all that. We have unit 256. Unit 256 is the highest. Okay, we have a lot of them. The highest here is unit 256. Okay, now all these unsigned integers have their different sizes. Different sizes is that the numbers of integer, the size of integer they can carry. Understand? The size of integer they can carry. You get? These guys are different. Units 104 with 104 and unit 16 is they are different. Unit these guys are of different sizes. You understand? These guys are of different sizes. Unit 200, unit 28. They are of different sizes. All right. So the amount of variable, the size of variable they can carry, the the character size they can carry is different. You understand? It's different. So if you want, there are different ways you can use them. You understand? So the largest of them is unit 56, so I can carry a lot. Understand? So in your own free time, can make your chats your friend, ChatGPT your friend. But I noticed that ChatGPT is doesn't really give answers to Web3 questions compared to Find. Find gives more more explanatory answers to Web3 questions than ChatGPT does. So I recommend you use Find, but anyone your hands can find, it will still give you something. It will still give you the answer. So you can ask what's the difference between um, the different sizes in the units, or same thing with integers and unsigned integers and signed integers. Even unsigned integers still have different sizes. Okay, signed integers have different sizes, unsigned integers have different sizes as well. So you can answer chats and then to tell you to explain to you their differences and all that. As a developer, you always ask so the importance of gas efficiency. Okay, it's going to tell you why one is better than one, or how one is used and how the other is used. Okay, so that's it. So what we're actually checking here is the size of this eight, this guy. So that's it. So for example, so I just use this for example. I'm just telling us so that when you are calling your in the nearest future, you want to use the SafeMath um, library. You can use the SafeMath library. All right. So my compiler is still compiling. Okay, we've compiled. We've done compiling. All right. So let me leave this guy. So I want to show you something. So let me just compile a new contract and sorry, deploy a new contract and add. Okay, so this new one I will add. And when I add, you will see that it's showing me error here. Okay, if I open the terminal, you'll see that I'm having error in the contract's initial state. All right, because um, the number cannot exceed the mass number. All right. So in the older version, it will still go. You understand? If I want to add number, you stand to still go, okay, until because it starts from afresh. This one doesn't start from afresh. Understand? It doesn't start from afresh. But if you want to implement this uncheck method in this new version, okay, you can just use the uncheck keyword. So we'll put these guys here. Oh, sorry, I think I used it. Okay, it's just say unchecked. 'Checked. All right, so let me store this guy. And so if I deploy this guy and okay, let's say that we have 255. So if I add to it, you see that it's going through because I added the uncheck to it. So see that I start from afresh. But if I remove this uncheck and this curly brace, it will check it and then call for error. But if I include this uncheck, it will not check it. It's just going to start afresh. Although it's not going to add more than the max number, it's just going to add afresh. It's just going to start afresh. Okay. So just put this in the back of your mind. All right. I just feel you should know about SafeMath. All right. So that in case peradventure we use it in the near future and you come across it, it will not be like magic to your ears. All right. Okay. Are we good?
Okay, sir.
All right. So our time is fast spent, but what we've learned so far is that we talked about loop, how to iterate through loops. Okay. We talked about I still remember the question that Kemi, yeah, Kemi asked, and I'll look into it. And then libraries, we talked about libraries as well, and how to create libraries and how to rats, and then we talked about safe maths. Okay, so in our next class, we'll be continuing our fund me contract. All right, and then so far we've we've created a function to add token, and we created a function to get price, to get real data price for fund me contract, and also we set limits so that people don't um give below $5. All right, so we'll create in our next class, we'll write a function to withdraw what we've received in the contract. All right, so we're able to see how contracts can send funds to outside itself, not just to withdraw, not just to receive tokens, but also to send tokens using a contract. All right, so we'll do that sharply. So when we are done with this fund me contracts, then we'll move into Foundry. All right, we'll move into Foundry and then we'll start testing our contracts and all that. Remember from the onset, I told us that the reason why I'm using Foundry for this course is because it's not just to deploy contracts, but also to test contracts, but also to do some security stuff in contracts, in smart contracts. All right. So Foundry is better used for smart contract securities than Truffle and others. All right. So having said that, any question? Any question? Okay, please look at loops, go and look at libraries, go and look at loops, go and look at libraries. Come back with your questions. I appreciate the question that was answered in this class. I'll go back and look at it again and then definitely get back to us. All right. So go and look at loops, go and look at libraries, come back with your questions, and we'll look at them together and we'll grow together as developers. All right. Let me so before we say good night, any question? All right, so